Okay, factoring. Factoring is the process of separating a polynomial back into a product. Now, a product in math is something that's multiplied together. So, say you have 4x squared plus 8x. That's the simplest form. The factored form would be 4x times x plus 2. That's a product there. Okay? And polynomials that can't be factored are called prime. Here's some steps. We're just going to get to it, though. So we need to factor these using the GCF. So we have to see what goes into 3x and 12. Well, 3 does. So we're going to divide the 3 out, and you're left with 3 that has to stay on the outside, and x plus 4. And then we can double check it, and when you do distribute that back in, you do get 3x plus 12. Now for C, there is not a GCF, so that is prime. And for E, the GCF there is 2y squared. So I'm going to divide out that 2y squared, and I get 2y squared times 3y squared minus 7y minus 5. You can double check it, and it works. Okay? You can do those ones. Those are the answers you should get. Now, factoring trinomials. Trinomial, remember, that means there's 3 terms in the form of x squared plus bx plus c. You first, to factor it, you must find 2 integers that multiply to be c, so the constant, and add or subtract to be b. So we have to see what 2 integers in our example. We have x squared plus 7x plus 12. What 2 integers have a product of 12 and a sum of 7? So that multiply to be 12, multiply, and add or subtract to be 7. Okay? So let's write out the factors of 12. Well, there's 1 and 12, which won't add or subtract to be 7. 2 and 6 won't add and subtract to be 7. 3 and 4 will, though. So it's 3 and 4. And then we just put them right into the binomial. So that's x plus 3, x plus 4. And we're done. That's it. Let's do another example. Oh, distribute to check, and you do get the same answer. Now let's do this one. So we have to see what will multiply to be 16, negative 16, and add to be 6. Well, we have 1 and 16. Nah, that's not going to work. 2 and 8, that will work, because we can do 8 minus 2. So positive 8 and negative 2, and that's going to be a plus 8, a minus 2. For u, we have to see what will multiply to be 40 and add to be 13. 1 and 40 won't work. 2 and 20 won't work. 4 and 10, we're getting closer, but still won't work. 5 and 8, yep. So it's positive 5 and positive 8. So that's y plus 5, y plus 8. Now for the last one, we have to see what multiplies to be negative 30, adds to be negative 1. So 1 and 30, nah. 2 and 15, no. 3 and 10, no. 5 and 6, yep. So that's going to be positive 5 and negative 6. So that's n plus 5, n minus 6. Okay, you can do those ones just for extra practice. Those are the answers you should get. Now, difference of squares. First, you have to make sure you have actual squares. So a squared term, let's just write some examples of squared terms. That would be like a squared, or 4, or 16, or 49, or 169, or 243. Actually, I don't think that's one. I lied. I'm a liar. Sorry. Whoops, made a mistake. Or y squared, or 9x squared. So anything that you can take a square root of, that is a perfect square. Okay? And then to factor these, if you have a squared minus b squared, that factors to a minus b and a plus b. Let's do some examples. So if we have a squared minus 4, that means a squared equals a squared, b squared equals 4. Square root both sides, you get a equals a, b equals 2. So that's going to be a minus 2, a plus 2. You can check by distributing, and you do get a squared minus 4. Now for n, that's not a subtraction sign, so that is prime. There is a way to factor that, but we're not going to get into it. You have to get imaginary numbers involved. Okay? Now O, so a squared equals 1, b squared equals 49y squared. Square root both sides. You get a equals 1, b equals 7. So that would be 1 minus 7y and 1 plus 7y. Double check it, and you do get that answer. You can do those last ones just by square rooting them. And square root in the calculator is the second and then the x squared button. Okay? Now these are just putting it all together. So let's do s. First we're going to factor out that 2. So you get 2 and then n squared minus 36. Those are perfect squares. The square root of n squared is n. The square root of 36 is 6. So that's 2, n minus 6, n plus 6. If we do v, we can factor out the 8y, and you're left with x squared minus 4y squared. Those are perfect squares again, so the square root of x squared is x. The square root of 4y squared is 2y, so that's going to be 8y, x minus 2y, x plus 2y. On w, we can factor out a 4k, and you're left with 4k squared plus 25. And that's it. We can't go any further because that's a plus sign. And you guys can do those ones right there. Those are the answers you should get. Now let's look at these ones. Always start with taking out GCF. So we take out that 4 and you're left with x squared plus 3x plus 2. We have to see what multiplies to be 2, adds to be 3. It's 1 and 2. So that's 4, k plus 1, k plus 2. We look at BB, we can factor out a 3a. You're left with a squared plus 10a plus 21. We have to see what multiplies to be 21, adds to be 10. 1 and 21 won't do it. 3 and 10 will, or 3 and 7, sorry. So that's going to be 3a, a plus 3, a plus 7. For DD, we can take out a 5y, and you're left with x squared minus 3x minus 28. You have to see what adds to be, or multiplies to be 28, adds or subtracts to be negative 3. 1 and 28, no. 2 and 14, no. 4 and 7, yes. It would just be 4 and negative 7. So that's 5y, x plus 4, x minus 7. Okay, you can do those last examples. Thanks for watching, and remember to take the quiz.